Hello. Hello, hello, hello. So did a bit last night that was off stream. So I guess I'll talk about that briefly. And yes, I know maybe we aren't that happy that I'm still working on the chess engine, but you know, I'm enjoying it a lot. So, and I think it's improved. I've improved greatly from my last chess engine, so I'm pretty satisfied with it. We are going to be doing research as we go along today, to make sure that we're doing things correctly. But want to talk about just everything that has happened since yesterday. Also pretty impressive that we've basically made a chess engine within 5 days, which is, we're kind of speed running it, which is kind of impressive. It's pretty awesome. Anyway, so to talk about what we did, we have to talk about the polyglot book format, which is it is a opening book format, which I'm going to pull up the information for. I'm hoping that this series, maybe someone that needs help making their own chess engine someday, will find it on YouTube and find it helpful. That's the goal. Anyway, from all of the research that I did with my first chess engine, I decided I'm going to open it up in a new workspace. Oh my gosh, I messed up my workspaces. I decided to go with the polyglot book format for my zobrist hashing. Now, there is some benefit to it. There is also some negatives to it. The main benefit is that it is completely deterministic, and that makes it easy to debug. The zobrist hashing is something in a chess engine that's notoriously difficult to debug. And so I think the main benefit of it kind of outweighs all of the negatives, okay? Because all of the keys that you're going to generate during runtime are completely deterministic, because all of the randoms are given to you. And that's what all of these are. It's a sequence of 781 random numbers, random unsigned 64-bit numbers. And if I can explain what these are used for, right, is that we have 4 types inside of here. It's basically 4 arrays in one, right? Which is what this describes. Oh, excuse me, my glasses are a bit foggy today. Oh my gosh. That's gonna bother me, actually. Anyway, so there's 4 types inside of here, right? So there's all of the combinations for all of the pieces, all the combinations for the castling flags, the en passant, and the turn. And I had a lot of trouble in understanding this and how to compute a key with my first chess engine. So I guess what I wanted to do for your sake, if you're interested in this format, is maybe talk about all of the pitfalls that I found in trying to adapt this format the first time. And now my hashing, as far as I'm aware, is completely bug-free. Anyway, we might write a routine that that creates keys from scratch and then checks our current key against it. We might do that today, but as far as I feel like I'm pretty confident that it's bug-free right now. So to explain what this is doing, right, is that inside of this 768 is all of the possible combinations of piece type and position. So that's what you have to compute, right? You compute 64 times this kind of piece, which is these numbers, plus 8 times the row, plus the file. Luckily, our rows and files are in the same exact order as theirs is, but our kind of piece isn't. So we had to write some additional transformation that transforms our kind of piece to their convention. So that's the first thing, right? That gives us the index into random piece. Into random castle, we have these. This is pretty self-explanatory, except that you're only going to use this when you toggle castling flags, which is more complicated than you would think with how we set up our castling detection, and I'll talk about that in a second. But the most annoying part of the standard is the en passant square, which I had an incredible amount of trouble understanding in my first chess engine. And the reason why is because it is not very simple. The standard Fen notation, right? When someone double pushes a pawn, then the information is encoded into the Fen string of the square that can be targeted by a pawn to en passant, right? And it's going to be the square in between, of course, their starting location and their end location, that square in between their double move, right? That is what is encoded in the Fen string. And that's super simple, right? Because if a pawn double pushes, all you have to do is when you double push a pawn, then you just set a new en passant square. Super simple, super easy. However, in the polyglot format, you only encode an en passant square if there is a possibility to en passant in the turn, right? So if you double push a pawn, you don't actually set the en passant flag. It's only set if you double push a pawn and there is a pawn there that can en passant it on the next turn. And this is, strangely enough, a much more inefficient and difficult task than just if we set the en passant square. So we have to have additional specific logic when we're making and undoing moves that checks, are these special conditions met, or we are not going to toggle an en passant flag. And in my last engine, I had to make, very interesting. What I ended up doing is I made an extra check on the move struct, right, and passed everything by pointer, and then inside of the move I had a slot for, are we toggling en passant if I play this move, and then when we make the move we basically set that information so that on undoing we don't have to recompute it. Here we didn't end up doing that because it's much more complicated than if we just simply make an efficient check. And so that was my goal this time, and I'm hoping that I did that. I did notice our perf has definitely slowed down in nodes to about 4 million nodes per second from back when yesterday it started at 8 million nodes per second, which it's quite a drop, but we are doing a lot of hash key updates, so it makes a bit of sense. Anyway, if white is to move, then turn gets sword. So if I'm going to explain this properly, I have to just like go into our make move, right, which has now become much larger than it was beforehand, right? Something. Hey, what's up, LHD Hawk? How are you doing? So you can see here that we are doing this new thing here for all of this, and I'll go through and explain what's happening here. Obviously, if our game side to move is white, then we Zor it, and we do that after we change the side to move. That's important because if we did it before, then we wouldn't know what to undo it on the other side. And so, as you can see in our undo move, we have this before we change the side to move. So you have to decide which way you want to do it. But that's the way we decided to do it. As you can see, there is this annoying specialized logic with the polyglot format, which is what I just talked about. If our move is a double push, we have to also check, and I do this by pre-computing this bitboard, right? If game pieces of the other side pawn, and the game pawn captures for our side to move from the en passant index. So what this looks like, right, is that we are taking the en passant square, right, which is the square in between where the pawn that's getting double push starts and where it ends. We get that square and we check the captures for our side to move from that square. And what that is it's basically diagonal from our current square in the pawn push direction. This is important because this also, of course, is going to register attacks on both sides from opposing pawns from that square if we AND it with the other side's pawn pieces, right? And so this is what detects if we are going to Zor the flag for the en passant random, which is what I just talked about. So that's the logic for that, right? And in my last engine, it was much more complicated because I didn't really have the understanding of how I can leverage pre-computed bitboards to avoid checking indices, right? Is that I would basically pop bits and then check pieces at certain locations, right? Now, as a better programmer, I know not to do that. Anyway, so that's that. Also, we have additional specific logic for our castling, right? We have to know if, unfortunately, in our movement generation and everything, we don't know what our flags are at the start. We just set, if we detect if a move will lose us our castling rights, and if it loses us our castling rights, then we just set our castling rights to false, right? We don't actually take a look at what our castling rights are currently. And so this was efficient, right? Because all we do is we copy our castling flags, what they were before, and when we undo the move, we just restore what we copied, right? And that's efficient for what we're doing. However, it is going to create us an additional branch when it comes to updating our hash key, because we have to know what our flag was before. And so we have to check if our castle flag was true, then we are going to Zor it, right? Otherwise, we're not, right? So, and we have to do that on the undo move as well. So that's what all of this extra stuff is. I've been learning C from this book, C Programming, A Modern Approach. Yep. It has good reviews and stuff, but I don't really get it. I feel like I'm learning more about C than learning to program in C. Do I have any tips? I didn't really learn C from a book. So I don't know if I could give you advice on how to learn from a book. I started with Java and JavaScript and all that stuff, and then I started doing Rust, and then I got into C because, it's my favorite language, right? It's what I, exclusively program in. If you want to learn C, I'd say the best way is to program some terminal applications, stuff that just takes certain data that you input and then manipulates it somehow, whatever you're interested in. If it's like, when I started programming, I made Minesweeper was my first application. It didn't have a GUI. It was just in the terminal. And then I did something that could solve Minesweeper with math, right? And then I did like a Sudoku solver and things like that. Those projects are going to teach you about like recursion and stuff and how to work with the data structures of C and maybe even some memory allocation stuff, C is a very simple language. When it comes down to it, there are basically just a few things that you need to learn, right? There are structs, which I can show you right now. We have structs, which just have data inside of them, and we have pointers, which are pointers to a place in memory, right? And we have to allocate to a pointer using malloc, right? To set it to some data, to allocate memory, right? And that's basically all there is in C, right? When I initialize my transposition table for my chess engine, all I do is I malloc it to a certain size, and then to get rid of it, I just free it. As far as C as a language goes, that's pretty much like it. Just like any other language, you have looping. You can copy data by saying int a equals p, this sort of thing, or you can do int pointer s equals the address of a. This is pretty much all there is in C, which is why I love it, because it's so simple. You have to admit, it is very addictive. Yeah, you were doing that Hunger Games idea. You were cooking last stream. Did you ask AI about it? Anyway, so that's pretty much what I wanted to talk about. That's pretty much all that I did off stream, which was the zobrist hashing, etc. And we have to write some stuff that implements this. I wrote some notes here that says if a move is quiet, it's a killer move, and if it approved alpha, we have to add it to the history table. Yeah, so to do this, we have to make a function that we've been putting off that determines if a move is quiet. And it should be a very simple function. So I think, honestly, I might just put it in header and then just inline it. So I'm just going to do static inline bool move is quite. We kind of want to make two of these, and we want the second one to be Ooh, I think that it's castling, right? That you kind of want sometimes. Let's just write a note here. Make one that that excludes castling. I think that that's kind of what you want at some point. Haven't written Python in so long that I literally didn't know. Yeah. So this is going to take in a move pointer move. We're taking in a pointer because we don't want to. It's faster to just copy the pointer. Okay, and to determine if a move is quiet, we have to go through some logic, right? So return if, right, you just do this. Return move type is going to equal capture. I think you also, promotions aren't technically quiet moves. So, and we also need to check if it puts the enemy king in check. And that's gonna have to probably be a different function. Oh no, we can just literally... Yeah, we already have a function that does that. We already have that up here. It's called in check. And we will just check if we're in check from the opposite side. Oh, wait, but we have to execute the move to figure that out. Ooh. I guess, I guess when it comes down to it, that this is where more legal move generation actually would be helpful, right? Or not purely legal, but if we had we could do two different checks here. Basically say if this, then we are going to consider, right? And else, of course, we return false. But inside of this, I wonder if it's faster to make the move or to just literally check if we're attacking. I think it's faster to check if we're attacking a certain square. Then we should probably have a function for this. Piece is square, and this is going to take in you don't know how to use the C++ API? Well, I don't know either, so you're not alone there. So I'm going to take in a piece type piece, a side, and I think that that's all the data we need. We can't inline this, unfortunately. Or there's no point in inlining it, so I'm just going to put it in game.c. And it'll go with art is squared attacked. It'll just be right above it. It's a bit of back and forth, sludgy learning process for me. It's also my first time programming. I've referenced lots of resources again and again. If I start a project, I quit when it's too complex. Go back to the book. Yeah, I mean, if you're definitely progressing, even if it's slow. I'd say the best way I've found to learn stuff, especially programming, is just to make projects and just like push through it and until you can't anymore. And then when you find something specific that you're like, oh, how do I do this? Like, just make a program until you get to a point where you're like, oh, I need to allocate some data, and then you look up that specifically, and then that kind of feedback loop that puts the information in your brain, right? If you come across those specific problems, and then you can look them up, right? I never was someone that could learn from books, I always sucked at that, but that's just me. That's kind of how I've learned programming, it's just you do something until you have to look something up, Okay, so we have to switch on piece type here because we have different attack tables for each piece, right? We need to check, so we're going to take in an int start square and an int n square that we're checking. And if it's a pawn, we will use the data for our side. So game pieces side pawn, and we'll check if return game pieces side pawn and pieces. Wait, hold on. No, not game pieces. It's game pawn captures for side start square and 1 ULL n square. And it's going to be the same thing all the way down. For knight, bishop, rook, queen, king. And instead of looking at pawn captures, we will look at knight moves from, this doesn't need side, just start square. And for the sliding pieces, it will be different, but here we can just go here and do the king moves. And if it's queen, we will instead do fetch bishop moves. We can take a additional thing here just to have it for blockers, and this will always, at least for now, be just all of our game pieces. And we're gonna go fetch rook moves from the start square with our blockers. And this is pretty boring, but what we're doing here is pretty necessary for us to determine what is and what isn't a quiet move. This is going to raise the elo of our engine exponentially, right? Well, elo is relative right now. Our engine is still essentially a baby, right? Now we have to edit the header file for this. adding this in. And here, of course, then we are going to check if piece is attacking square for our move piece with our move side from the start square, which is move start index, to move end index using our game board pieces both as our blockers. Then we will return true. Else we will return false. And I will write a note here that this is checking. Oh, we don't actually, before I forget, this is actually end index to our enemy king, right? I almost messed this up. So game pieces, not move side, king. And this is, what this is doing is it says, if we complete this move, will we be attacking our king? Of course, this is going to have to change if it's a promotion. So let me do that. So this is going to be different if it's a promotion. So if it's a capture, else if move type equals promotion, then we need to, of course, not use the move piece, but the promotion piece. Else we will return false. So if our move type is promotion, then we aren't obviously going to check with a pawn, but we are going to check with the move promotion type. Okay? Because of course if we promote to a king, then we want to know if our move is attacking the king after we promote. That should be our function. And we are going to use that in multiple places, namely in our Q search, right? This uses static exchange evaluation to get rid of moves. Now we can get rid of this. We can get rid of this, and instead just say if move list I, wait, if is move, hold on, what did I call this? If move is quiet. Actually, this does this return if move isn't quiet? Hold on. Yes, it does. So this should be switched. And I'll write a thing here. Returns true if move is quiet. I've been looking into like physics 2D like simulators. Those seem fun. Yeah, for sure. There's a lot of you know, really cool YouTube videos with them doing those physics simulations with like the balls and the colors and stuff. Yeah, that would be a really fun project, I think. I think that would be sick. Okay. Wait, hold on. The logic for this is wrong. The logic for this is wrong. Promotions are always actually noisy moves, at least from my understanding of it in my engine. So the logic for this is 100% wrong. This goes in here, and then this goes to false. Okay, no captures, promotions, or checking moves. Okay, so if move is quiet, then we want to return here. Or continue, rather. Okay, I wonder if we see any increase here. Well, I also included kind of this PV line, which uses our transposition table to find the PV. We are finding very strange best moves. Reason being, why this is so high is because I wonder why this is such a high score, but we don't have p-square tables, so we don't really know where to develop our pieces yet, so that's why we're getting weird moves. I'm wondering why this is so high in terms of score. I believe that that's probably... Is that actually... This score, by the way, is our sort score, not actually what we score a move. Interesting. Oh, right. So this is... Oh, that's why. Because our best move is always our PV move. And so our TT move always goes first. So this is exactly what we want to see. In fact, I'm interested in why these moves don't have the high score. And I wonder if that's because we are including... Huh. Interesting. We should only be, right now, including moves that raise alpha as into our transposition table. I wonder if we start... I wonder where that move is coming from. This one is B7, B6 entry. A2, A4, A7, A6, A4, A5, B7, B6. B5, A5, B6 capture, C7, B6. It seems like the last move always has a score of 0. I'm not sure why that is. A sort score of 0, I mean. This is, would be at 0, 2, 3, 4, 5. You know why? It's probably because it doesn't get sorted, but it still probably is correctly the PV move. It probably just doesn't get we could probably get around this, right, by saying best move score equals this value, right? Because then it will always be that value, and we don't have to worry about. Okay, that didn't work. Maybe it has to be when we the issue is that this this pointer sometimes doesn't get set. So it would have to be just here. Also, I'm getting these empty moves now. That's actually... Yeah, it seems to break the chain when I did that. Strange. Basically what this is that we are following transposition table entries to the next move. But we are apparently storing null moves here. The thing is, I think it's always one past search depth. So we can get around this by only following... Right now we go in a while loop. But I suppose we could, instead of going in a while loop, we could just for loop it instead. Because we are making TT entries without best moves. What we also could do is we could just like literally make a flag in TT entry that says has best move, and then when we make a TT entry, we could just literally just fill it with that information. We can just literally do this. And then when we're printing out our PV, we can just literally, I'm saying it a lot. We could say, if not entry, if not entry has best move, break. And that should get rid of all of those empty A8, A8 move, null moves. What I'm confused about is why it breaks here. Why the chain breaks here. at depth 6. See, all of these work fine until here. I wonder if it's because we don't store beta cutoffs, but that shouldn't affect the PV. Or maybe it does, because this is now working. I wonder, maybe I should try another fen to try to see a more active position. The annoying thing is that a dip... Now I'm just getting the same line every time. One, two, three, 4, 5. This should be 1 extra, I think. Let's go for 15 seconds and see. See, this continued properly this time. But sometimes our PV just gets cut off. And I wonder if it's because we're like overwriting entries or something. Maybe we should search first. So if we find one that has our key, if the already pre-existing, I think that this is how they do it. If the pre-existing entry depth is greater than our depth, then we return and don't store it. Now it doesn't seem like we're storing anything. It's less than? I doubt that it's less than, though. Yeah, now it isn't working at all. Maybe we should set the best move. Regardless. I should really just get the entry at this point. I mean, now we are setting the best move. Huh. Yeah, maybe this isn't what you're supposed to do. I don't know. What is this song? This song is crazy. That song was crazy. Not the current mood. If I don't create exact entries, does it... Yeah, it appears to work if I don't create exact entries. I think that this is how I'm going to keep it. I don't know if this is 100% correct, but maybe it works fine and I'm just not... I'm being too strict with how my expectations for the PV. I'm definitely like over focusing on this right now though. Also something that I noticed though is we don't want to do current best. It's going to be search data. I made this struct called search data that does the current best. Okay, so let's implement the history, heuristic, etc. into our thing now that we have quiet. So if our move is quiet for our move, then do this. I believe so. And then if we improve alpha, then we add it to the history table. We were already doing this. Now it's important to go into our sort moves, and we want to put search data into here. And then this will have our history and stuff inside of it. And so we want to score based on those things. So we're going to score moves here. We need to take in our search data here too. How do I use killer moves again? I don't really remember. Isn't it indexed by ply? I think so. Yeah, search data ply. And my ply hasn't been working, so we have to fix that. But for now, we can just use that, I guess, to set it up at least. But yeah, we have to fix our ply thing. It also might not be possible to put ply inside of search data, but whatever. We have to check if it is the killer move, right? So we should make a function that does that. So I'm going to make an inline function that compares two moves. So move is equal, and it will take in a move A, and this is going to be exactly what we did over here. This is my heuristic for determining if two moves are equal. If the start index matches and the end index matches, and also if we're a promotion, if the promotion type is the same. Just making sure I do this right. And then we are going to change move to, it's better to change best move first, because then we don't have to worry about search move to A. And this is return true. There we go. And that's all of the cases dealt with. Okay, so now we can remove this, and just if move is equal to best move, if our move is equal to best move, then we can just set the score to this. And then inside of score move, I'm going to do the same thing for our history heuristic and our killer move. If move is equal for our move and this move, we have to pass the pointer to it. Then we will add, I think it's just a pure value. For if it's a killer move. Typically, it's scored after the MVV LVA moves. So I guess in that case it would be 100. And then we have to do the history heuristic. Which is the history indexed by the move side, by the move start index to the move end index. Is it just that? I'm gonna have to print out what we're looking like, but maybe that is it. So I'm down to give it a try. It's just that our search data apply is going to be going negative because I haven't fixed it. So yeah. Whenever I returned, I was subtracting ply, but maybe that isn't. Hey, what's up, y'all? Finally installed Windows and Arch Linux. That's sick. I'm glad that you figured it out. I wonder if I can just, let's try to just remove ply from our queue search, at least for now, and just literally do it here to try and get that working first. My idea was that we +1 when we go down into Enigmax, and then we -1 when we go up. But if we do that, then we can't do this. I probably will segfault here. Yeah. Because our ply isn't correct. Well, of course our ply would have to go +1 here, and then -1 here. Yeah, segfault. Huh. It's all about UEFI, yeah. Yep. That's what you gotta use to install Linux for sure. I wonder how I can debug this. You're trying to do it with legacy boot? Yeah, the tutorials I've followed just use UEFI. You know, maybe it is just better to pass down a parameter instead of this pointer. And just go apply +1. Probably make this a lot simpler. Oh, I'm still using it, the wrong ply. Let me just try using this ply. Still seg faulting. Where else am I using that ply? Am I using it in the Q search? I was using it here. We also need the ply here. And so we need to pass that down to Q search as well. And then this is going to be ply +1, right? But this is just going to be ply because we aren't incrementing when we enter Q search. When we sort, we should always be at ply, and when we go down, we should always do ply +1. I think that's too few arguments to sort moves. It's a score move. Inside of the root, we also have this. This should be 0. I guess that. We get a seg fault. Why is that? Why is that? Oh, I have to check if best move. Because that's a pointer. Okay, I have no clue if this is working. It's kind of impossible to tell without actually printing out some moves that we're generating. I want to get a fen from the chess programming wiki. I'll just get Kiwi Pete. What I should do is I should really just like make a command that you can set it to a predefined positions. I should like hard code some positions in. And let's go best move 15. And we do see some stuff happening. These are all MVV, LVA. I'm kind of... These are static exchange, I'm pretty sure. Yeah. Honestly, we should probably just like do that. I'm only seeing captures getting scored though. So I don't think our history heuristic is working. Because I'm only seeing captures getting scored. I'm interested to see if my move is quiet is broken. Yo, what's up, Yash? Scoring or position searching today? Yeah, so right now I'm trying to implement some basic heuristics for move scoring, which are killer moves and history heuristic. And you know, we set up a static exchange valuation and MVV LVA already, but I am not seeing quiet moves getting scored. So I think we're broken somewhere. I'm kind of interested to see if I remove my TT entries for this stuff. If we start getting it. Maybe I should. Oh right, I have to put in this other fan. No, I'm still only seeing captures getting scored. Let me try something out here. Sounds fun. Last time I tried heuristics was A-star. Really? Yeah, I did A-star as well for my game engine. It's such an interesting algorithm. It really is. I don't really understand it even though I implemented it, to be honest. I'd be lying if I said I understood it at all. Maybe my ply is wrong. Let's try like 5,000 for this. Oh, that's why. No, I'm being stupid because I didn't actually. I'm only scoring moves if it's a capture. I never actually score it if it's There we go. That's just me being dumb. Yeah, and now we see our moves start to have scores. There we go. I still don't see any killer moves, but this is from start position. Oh, this is a killer move. There we go. It's the 100 that we wanted to see. The reason why it's 100 is because we want it to be under our lowest MVV LVA. Okay, so this seems to be working. Let me try the QEP fan. And let's see what numbers we start getting. I'm kind of concerned about the negative int max moves. I'm pretty sure that that's a static exchange breaking issue. Also, I'm not sure if negative static exchange should necessarily... Yeah, I don't really understand how the whole static exchange thing works, not gonna lie. And there might be bugs with it, so I might just comment it out for now. Is it int max overflow? I don't think it's overflow. I think that there's maybe infinite recursion instead of my static exchange counting. Or not infinite recursion, but you get the point with how I'm scoring it. Because if I go back to that fen and I do best move, you see that it's gone, so it's definitely that. And there is a while loop inside of static exchange. Basically, what it does, I kind of copied it from my old code base. It just basically makes an attacker masks for both sides and then pops off bits till that are attacking that one square that we're moving to. But obviously it doesn't work. And I don't know where the issue would be, or honestly how to test it. Like I could try this, maybe having this depth check here just to make sure that we don't overflow, but I don't think that it is overflow. This gain is adding the piece values LVA minus the gain of the previous depth. And then at the end, you loop through the depth. Yeah, I wonder how the overflow could be happening. What if I try this, not switching at the first one? Maybe I'm messing up my sides. Oh, I didn't re-enable it, did I? I also tried just putting this doesn't seem to be working at all now. Oh, because I didn't add it. Okay. We're not overflowing anymore, but I'm not exactly sure if that's happening like it should be, and I don't really know how to test it. kind of hard with stuff that you don't understand how to test. But I may have to tinker with it later with some test positions. Honestly, I'm probably just going to spend a lot of time on the chess forum again, like I used to, trying to figure stuff out. Okay, so that's all implemented. Now we can stop printing out moves and see how our search, I guess, statistics have improved. I see that our PV isn't getting tracked anymore. I wonder if I commented out something. No, I didn't comment anything out. Sometimes it finds the PV and sometimes it doesn't. Yeah, like here it finds a PV but then drops it. I'm unsure why that is. I also didn't know if I should be returning this score or if I should be returning the bounds. But I don't know if that's going to affect anything. I also almost wonder if our zobrist hashing is 100% working. Like this returns it to what it was originally. But if our hashing is off, then everything is going to be off in terms of our TT entries. What we want to see, by the way, is all of the moves at this score, because this means that they're PV moves. Why don't I use debuggers? I do use debuggers. I mean, I don't think GDB would help us here at all. But I do use GDB obviously with my game engine and stuff, or when there's a stack trace that I need to do. But with something like this, it's probably a logic error in how I'm doing things. rather than any sort of like memory, thing. It's probably me just not understanding something. I also feel like when you create a TT entry here, it should be depth +1 because you want it to reflect basically what I'm checking for here is that the way we track our PV is we just literally follow our transposition entries from 0, right? Is that once we get out of here, we do our current best, right? Move, and then we follow it down. But it doesn't seem to be working. Yeah, I'm probably gonna have to just like search and do research on the on more research on the wiki again, like I used to. Does best move... Wait, hold on a second. No, best move does get stored in the table. That's what it is happening. I'm wondering if it's null moves. So let's remove the check for if entry has best move break. Let's remove that and see if we get A8, A8 moves. Yeah, we do. Here we don't get an entry though. Yeah, there has to be some bug somewhere, because this isn't supposed to be what is happening. Let me try and get rid of the early outs from our transposition table just to simplify things. And let's just get rid of QSearch completely at this point, just to make sure that we're doing this correct. You know what? I probably have to... set up a separate variable, actually. We should make a variable that's move pointer new best rather than best move, because best move is the one that we already found from our transposition table, and new best is from the move list, and new best is the one that we want to always register rather than the best move. And that best move is the one that we want to use for sorting. Let me see if that changes anything. There we go. There we go. I think that this is what we want to see. We should have exactly 6 if we're going to depth 6 is what I wanted to see. See, so when we're at 3, we have 3. See, at 4, we're dropping. We're still dropping. Sometimes. I wonder if this means that my hashing is wrong and that I should... Or if my hash keys are colliding or something. I'm not sure. From the start position, it seems to work fine. And we're setting up our key right at the end. So it's only not working with a complicated position. We are dropping. Is it possible that we just don't get a PV move, or is that even like literally a possibility? I don't know. Should I be using negative int max or like a really low score? Like maybe that's the case. Maybe I should use something that's just large. I don't know. So you know what? Let's go back to what I was gonna do before, which is literally make a function that checks hash every time we make a move. And we'll make a new command for that. On command debug check hash. And what this command is going to do is it's going to recreate our hash from scratch and check it against our current hash for every board. But I have to, of course, implement that into our current loop for commands. Which is getting large. We should probably move it into a different file soon. Windows 11 is garbage. I agree. I definitely agree with you there. So let's go command. I also think like the ads that they put out while they were doing that were really, really interesting. Okay, so this is going to take in check hash, which will run an iterative search. It's just going to be best move pretty much, but it's going to pass down an additional argument into iterative search. Honestly, to keep this nice and tidy, what we should do is create a new struct called search flags. Which will have a float max time, and for now we'll just have a bool check hash. And search data will take in will have a search flags. But the search flags is what we're going to do up here. We'll have search flags, and we'll do the same thing that we do with our best move command, and we'll just take in the max time. And we'll say flags dot max time equals max time, and then we'll just set the flag check hash equals true, and we'll pass this down instead to iterative search. I don't really care about this being very efficient or whatever. It's just whatever. Okay, so the reason why I want to do this is because we will now inside of here, we're passing down our search data, and during this, after we do every move, every time we make a move, I want to do the check hash command, which I haven't made yet, but okay. So our check hash command, check hash, is going to take in our game, and we are just going to check we're gonna have a UN64T create zobrist from scratch for our game. This should return create zobrist from scratch. This should just return key. I have to change it in the header. And then add this to the header. I mean, we can just inline this, to be honest. Okay, now we should get some errors in here. We have to set up these search flags for each of them now. I can't spell flags. Okay, we also have to I just want to print this. And remove the print from here. And then what we will do for when we're checking our flags, which is inside here, inside our negamax, check hash. If check hash for our game, if it comes back false, I want to detect a misalignment and then print out both keys. And then print out the scratch key, which we will create zobrist from scratch. Okay, so let's see if we get any. Oh, fuck. Oh, shit. Okay. So we will get a fen now. What is this? Output game to fen. And then we will output the fen. Oh god. Alright, so let's do some testing here to see if we're really misaligned. And to use that, we're going to use a tool called polyglot hash generator. There's a GitHub for this. And it's telling us that we have a... Oh, yeah. So this was just lowercase. Okay, so we have our answer. Our keys are incorrect because this shows us that our scratch key is correct, 958E2, but our key is incorrect. So let's do some. Okay. I want to try to return out if we get this. I want to see where we are misaligned first. Looks like that's going to be hard to check. Looks like that's going to be very hard to check, actually. Let me check this then. Also, it's going to give us wrong position because this is... Why is it telling me wrong position here? What's the problem? Trying to see where I'm off in my fan, if I'm generating fans correctly. It's going to be key. So 1, 2, 3, 4, 5, 6, 7. Okay, so my count is wrong. If I change this to 3, it's going to work. Okay, so let me check this out. It appears that this is incorrect. My output game to fen has to be absolutely correct for this to work. I made this last night. I don't know if this is correct. So let me check this out. So if we have a piece here and our empty space counter is greater than 0, then we do this. Else we increment the empty space counter. And if our space is the end, trying to make sure that my logic for this is all correct. Because this is off. And I don't really know what the board is supposed to be like is the problem. 6, 7, I think that the problem is that this is supposed to be a 2 probably, but I'm just kind of guessing there. And if I move this to here, this isn't going to work, I think. Yeah, that just breaks everything. D space counter equals 0. Why is this wrong? Maybe hold on. Maybe this isn't wrong and I'm wrong. No, we're only getting 7s now. Oh, this has me pretty worried. Unless, I mean, this should be right. Like this outputs correctly. And then I go to display, it should output the fen. Let me see. P2 Q2. 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 q 2 p 2 PPPPR. NBQ. Wait, what? Oh, I fucked something up real bad, actually. Wait, what? Why is this off? Maybe I edited something that I wasn't supposed to edit. What? Oh wait, this fan is wrong. Oh, I'm being dumb. I'm being dumb. This fan is wrong. This fan is not what I thought it was. This is the fan that the fan is wrong, not my engine. Yeah, I was super confused. The fan was wrong. It's still, the output game to fan is still not working though. For sure. Like, if I use this fan that I just output, I wonder if this is a legal fan. Yeah, it is. It's hard to tell. Like, if I best move from here... we get a bunch of fans that don't make any sense. Like 1Q1 with 3 kings. And then if I use this fan, this is legal. Oh my gosh, please. This is legal. Somewhere I start... Oh, you know what it probably is? Hold on, I'm just being really dumb. I'm actually being incredibly dumb. It's because we returned 0 there. That's probably why. Because our board state probably gets messed up. Not our fen generation. Our fen generation is fine. It's just this that's capital. Oh, okay. So it's hard to know where we're off is the problem. Like, there's really no way to tell. I mean, we know that it's in our make move and undo move, but I don't know. I don't know where it would be. We probably need to make some test fens. Just to test. We always know that we should Zor with the en passant random, right? Ah, that's what it is. Wait, never mind. This does... offset plus index modulus 8. Let me check this. Oh my gosh. Let me test if this function is correct, because I do it a different way here. It would be game en passant index modulus 8. Now if both of our keys are off, then we know. $6.44. It would have to be one with an en passant square, I think, to check, but... I'm pretty sure it's the same thing. I don't think order matters. And this is exactly the same, right? As I... Yeah. Maybe it's this. Maybe you have to only zor it once, or does it not matter? I don't think it matters, right? My theory is that it doesn't matter, but maybe it does, I don't know. In our I kind of wonder if our perf is correct now, just to make sure, like absolutely sure, that we're not going crazy here. Yeah, our perf is still fine. Yeah, our perf is good. But the hashing is not. It's not. The thing that I don't do you have to zor it with 0? That's something that I don't do. I don't know if that's important or not. Actually, I don't think it is. And this matches the website, right? White, Schwartz, 0. Don't I have to Zort with 0 if we get no flags? Is that has something to do with it. Also, I'm pretty sure that all of this is just bullshit that I just did. Nothing is really screaming out to me right now. I can test something really quick. I want to test something. Inside of our move, if I want to just try this just to test it. Where before I do a move, I do move old key. And then we simply restore that at the end. I want to try this. Oh, this is my undo move. Hold on. Yeah, I'm gonna try this. Just to see if it's in our undo move only. Or what? Okay, so let me test now. No. No, we're still misaligned. Five BD. And this is, yeah. Yeah, the only way is going to be to return out early. And my idea here is to return a certain score. Let's try negative something really big. Let's try negative 5 million, which is bigger than our maximum beta. And then if current score, we have to do this after the undo move, by the way. And then if current score is less than, like, you know, that negative 2 million, then just propagate it up. And that should exit us out when we first meet a misalignment, I think. Oh my gosh. Hold on, I want to search a way that I can just like... Okay, it's exit. I can just exit. What is this in? There we go. Okay, so this is the first place that we misalign. Which it's helpful to know this because we can know what's weird with this position that causes us to misalign. Our key is 931. We need some extra information here. Let's do this. And let's do the same thing up here. And then we make the move. And then we undo the move. And then after the undo move, we exit. And then we should get 3 printouts here. We got 4 printouts, so I'm not sure what that means. We may have to step through it, I guess. How do we get 4? In what case would we get 4? Oh, in this case, if our check hash is wrong up here, but if our check hash is wrong up here, then it's on a make move. It's on the make move before we get into here. Okay. Let me see something. Okay, this doesn't work. Hold on. Where did we start? Was it here? I think it's here. It's still the same exact one. Huh. I wish I could get the position before this, but I think it's literally just the pawn. It's literally just the pawn move. Huh. Why does position fen not work for this? Is it this that's the problem? No move found. Oh, it's because of fen. And our key is correct. But if I do... Okay, so we're gonna try this. I'm gonna try to give it the start position fen. We get our key. Our key is wrong. That key is wrong. That key is wrong. Oh, it's because of en passant square? Why would that en passant square thing even return true for that key? Doesn't matter right now. Let's perform the problematic move A2, A4. Let's get the key from scratch. That's correct. Oh, but the key from scratch doesn't tell us our current key. That's the problem. Okay. Then let's make a command that does that, I guess. Or we can edit our existing command for the meantime to just give us our current key. So we're going to do this and then get our key here. 931. And let me get the display. Will give us the fen. And let me put the fen into here. And yeah, it's wrong. It's immediately wrong. Okay. And why is that? Now's the fun part. Now we get to go through and try and figure out why. It's obviously in our make move because let me see side to move equals black. Let me test this. Move A2, A4. Key. Nope. Not the correct key still. I don't think you can use XOR with 0. I don't think that this is a thing. Is this no, this is, oh, I forgot to turn this to white. But this would still be wrong. We definitely don't toggle any. We definitely don't do any of this. It's definitely not that. Let me check this out, actually. Good question. A2, A4 key. 931. No. It's the same thing, so we don't get into double push. Is it really our regular move? That's not correct either. Let me get our start key. Oh. And set board defend. Oh. Oh, I never actually... That's what it is. Create zobrist from scratch. Never gets called. Wait, how did I not know that? Whenever we set board defend, we need to, at the end, create zobrist from scratch. Wait, how did I not... What? I must have deleted something. And then let's do move A2, A4 key. Okay, so that's still wrong, actually. But the start position is fine. Hold on. Okay, so this is still wrong. But is it, did I change anything here? No. Huh. Let me test this again. Okay, so that's the correct key actually for this position. So I guess that my turn random was backwards. And so if we were black and then we set it to white, then we... Okay, so let me check hash from here, from start position. Check hash. Okay, we're still getting misalignments. Let me simplify this down so that, because it got very, very complicated, obviously. We do have a misalignment detected at this position. Okay, so our scratch key is correct. It finds the misalignment at the same place. Alright, so let's play out these moves. Let's move a2, a4. Check the key. We know that that's correct. And now let's move, what is this? a6, a5? No move found. Maybe it's a7, a5. a7, a6. Key. 63-3. Let's get the fen. Or let's display the board. This tells me it's FF05, which we know is correct. But we have it incorrect. Oh, hold on. What's that? No. We still are off. And this is definitely the position that I have on my other screen. Yeah. And this is with no undo moves. This is still not working. This gives me correct. If I just don't have the side to move check. So let's try that. Let's try with no side to move check. And that we just do it every time. We get a misalignment detected. But it's deep, deep, deep in the search tree. Our key from scratch is correct, but this, let me check the en passant. So it's a B3. I think, so if you want to see what I'm looking at, hold on. It's this, what I'm looking at is this. I'm trying to see, there's this pawn here, this pawn and this pawn. I believe that it's an en passant issue, because this pawn could have been en passanted. Do you see what I'm saying? So it's our en passant may be wrong, our en passant thing. Let's try getting rid of the en passant. Yeah, I remember the en passant thing being so fucking stupid. if game piece is not game side to move pawn, so the other pieces and the game pawn captures for our side to move at the en passant index. Yeah, that should be correct. We know that this is correct. Yeah, I've got no clue. Let's try getting rid of this en passant random, I guess. Yeah, it might actually only be... It might actually only be on double pushes, if we think about it logically. Is this the same position? D6, 8. This is an en passant position, just like before. Okay, so what I'm seeing is that this should be side, I think. Let me try that. The other pieces and our pawn captures, and then when we undo it, we need to do the exact same thing. So not side, and our captures again. We're still off. You know what I ended up doing? I remember when I went through this process last time with my engine was that I made a hash checking thing that it literally I would print out the hashes and then hash them myself to figure out what it was off by. I'm hoping that I don't have to do that this time, though. Game en passant index. It should be this, yeah. Let me try it with this again. Because logically we should be toggling it on en passant as well. We're still off on the exact same position. Can I want to print out the move as well. I want to print out the move for this. Let me see the move, because then if we can undo the move, The move is f7, f6. Let me display the board just so that I can figure out where that is. So f7 to f6. This is completely unrelated. Let's move this up here. After our make move. Yeah, after our make move. Let me see. B2, B4. Yeah, it's hard because we don't actually know. I think it actually is B2, B4. Yeah, I think it is actually after B2, B4. I want to try. The thing is, I don't have the move history, so I don't know what move came before it. So I don't know about the en passant square before this. What I could do, and what I am going to do, is some deep debugging thing where I'm literally going to, after every make move, I will output game to fen, and the move after every make move. And the reason why I'm going to do this is because I absolutely need to know where we're off. So what this is telling me is that we make b7, b5, we undo it, and then we try b2, b4. And then it misaligns. And b7, b5... Oh no, b7, b5 is the other player. So b7, b5 we do, and then we reach b2, b4. Okay. In b7, b5, if we display and pay attention to the fen, then b7, b5 is the en passant move. That puts this pawn here, and white's pawn can capture with en passant. And then when we push b2, b4, then everything breaks. Because we don't undo this flag. That's why. Even on make move, we have to check if the last move was a en passant, even if it isn't a double push, because we need to or the flag. So else, okay, so how do we do this? This is complicated. This is for sure complicated. Okay. This is why I hated this. I remember now. Okay. So we have the en passant. We will have b6, right? Currently, we'll have b6 as the en passant square, right? Right. Yes. We have this. So if game en passant index, how do I check for this? Hold on. It's going to be, it's our side to move pieces. Game pieces side pawn. It's the opposites. It should be the same, the opposites. Now, how do I do this in the undo move? Do I have to do it in the undo move or not? Yes, I do. With the last en passant square. This is fucked. Hopefully my logic for this is correct, but I'm not entirely sure to be 100% honest. I think you're doing the opposite here. But honestly, fuck if I know. Okay, we misalign immediately on a7, a6. Hold on. Hold on, let me check if move last en passant square doesn't equal -1. So that we don't go out of bounds, I guess. And let's check if game en passant index doesn't equal -1. Okay, so we have a very similar position here. a4, a5. So this is pushing our pawn into this location, which is next to the en passant square. Oh, because in this case, ah shit. shit, hold on. In this case, this logic doesn't work. Because we had an en passant index and now it isn't valid. But if I move this down here, then this doesn't work. I think we have to actually check. I think we actually, I mean, this is fucking dumb, but I think we have to check it up here as well. Okay, we misalign immediately. On A7, A6. If the pawn captures from not side. Fucking Christ. Okay, so if we have an en passant index, I believe this should work. Wait, maybe you don't need to check after, maybe just before? Holy shit, did we do it? Fucker. I was so confident for a second. I was so confident that we were out. So we get, so yeah, we, from scratch we get the right one for this position. But so, it looks like B7, H1 capture. So let's go to this fan. And then display it. So in this case, B7. What the fuck are you talking about? B7, H1 capture? Wait, what? How do our pieces even get into the... How does this knight even fucking get here, to be honest? What trip did it take? Wait, what? It went here, here, here? And then this rook moved over? Oh, and then this moves up, and then this captures here. I see. I see. So after this move, what's happening is that we lose castling rights for white. We have now officially lost both castling rights. And so I'm wondering if that's an issue here. I'm pretty sure that it's a castling rights thing now. So, in our make move, I don't know if it's in our make move or in our move, or in our undo move. It looks like it would be in our make move, but I'm not entirely sure. Anyway, so this is how we check if our end index is the root, is the rook starting locations for the other side. So if we are moving to where their rook is, we know that they can't castle. And if it was true for queenside, then we do the castling random thing. Because they're losing their rights. And then how do I undo this? If our game castling flags for queenside don't equal the move castling flags, then we know to zor it. See this, it should not get into loses rights, because loses rights is only for your side's pieces. This is specific for capturing your opponent's rook. And this isn't backwards, right? My rook starting locations are not backwards, right? I feel like we would know if they were. Yeah, it is queenside first. Oh, shit. There it is. Okay. It was just a typo. Oh my gosh. That's just a stupid typo. Okay, thank God. Holy shit, did we do it? There we go. I'm pretty satisfied with those results. I wonder if we can go back to this position and then do some check hash as well. We can probably get rid of all this debug now. Alright. That's nice. Okay. So it turned out that I'm gonna keep this right now. I'll say if search data search flags dot check hash, then we will check our hashes. But otherwise we just won't do that. Okay, now do we see any improvement now in our search? Step 6. I think I changed Q search off, right? And I changed some TT entry stuff because I was just making sure that we weren't doing any buggery, I guess. Okay. And now for the first time, we actually see that B2, B4 is the best move, which I'm not 100% sure if you're if you're right about that, but I'm interested to see it from this position. Yeah, so our PV still is getting overwritten. I'm not sure what the what is going on there still. So I'm not sure if we're supposed to be storing that or not still. Or just the best move, I guess, I don't know. Like this fixes it, maybe? I don't know. Anyway, I am probably going to take a break now. It was cool that we figured out the zobrist hashing issues. That's fun. But yeah, I'm not really sure why the PV keeps getting lost. I probably am doing something wrong somewhere, I guess. But who knows? And who knows if this SEE is still working, so I can probably just like disable that. So the line it's saying is e2a6. So we take bishop and then b4 c3. Okay. This is not a possible move. This is not a legal move from this position. Which is not what you like to see. Yeah. So our keys are correct, but we still... I'm also not sure if I did this right. I don't know. We still see this B4, C3. Oh wait, no, this is a legal move. What am I talking about? I'm so dumb. B4, C3 capture is a real thing. Yeah. And then B2, C3 captures back is a real thing. But we do lose the PV, you know? So that's still an issue. But it appears that our hashing is now working, which is kind of the most important thing. Like, that's what I care about the most. I could actually check here. I'm pretty sure that it's this, that we don't find a best move specifically. Actually, hold on, let me print out, I'm lagging quite a bit. Yeah, so it is no best move found every time we lose the PV. We find an entry, just no best move. But obviously here, 1, 2, 3, 4. I tried this earlier, but maybe I should try it again. Basically what this does is it checks if we have an entry already, and if it's a deeper entry, then we don't overwrite it. I don't know if that's correct or what it is, but yeah. Well, I think we made good progress today. Definitely need to do some testing, but from what it seems like, that removing that line, it completes the thing. So yeah. Now we're getting PVs as long as our our depth. Or sometimes even longer, it seems like. I don't know how that's possible. Like, let me check these moves out. So it says D2, C3. Take C3. And then H3, G2. G2 capture. And then F3, G2. And then E65. Yeah, those are all legal moves, so. Huh. Yeah, so, I mean, it seems to be working pretty much. But we still have a bunch of stuff to implement. Like, I think that we might be able to leverage this now, which is, I forget what this is. It's delta pruning within our Q search. The next real thing we're going to have to look at is oh yeah, this is what I wanted to do. I wanted to make our evaluation not be like this, and just actually keep it on the struct for the game, actually. So that's what I'm gonna do. I'm gonna say int material evaluation color max, and we're just going to change that when we take a piece off instead of doing this. So instead, our evaluation function is actually just going to be like return game material evaluation for I have to get rid of this, it's mad at me. We can also take in the side, because we might want to evaluate from the opposite side. Side. Not side. And then what I'll do is what I'll do is just keep track when we make move. And so yeah. Is there a graphic yet? There's not a graphic yet, unfortunately. What I'm probably going to do is just make it UCI based and just use Arena, which is the suite that that chess engines communicate with each other's and play games in. So yeah. So material, we want to change the material evaluation when we capture. So for not side minus equal piece values for the move capture piece. And we'll do the same thing, obviously, en passant. we want to change the evaluation for not side for move capture piece. And we want to do the same thing when we promote. We want material evaluation for our side to add the move promotion type. And then if it's a promotion capture, we want to do the same thing for capture piece, etc. Okay. So all of that should work. We also need to do the undo move. There was something that I wanted to do though. I forgot what it was. I wanted to, oh yeah, I need to initialize it when we set board to fan. I need to, oh actually in that case I kind of want my old evaluate function. And just call it int init evaluate. And this will be game evaluation for side, and we'll side to move is fine, yeah. And when we set board to fen, I want to, at the end here, where we create our zobrist, init evaluate. Okay, and we need to do this. If you keep this now graphic trend, you will not have a girlfriend eventually. Interesting. Well, I don't have a girlfriend, so that would be, I would be like, that would give me -1. Okay, so in my make move, I have to copy the material evaluation into the undo move. Proven. That's cruel. That's so cruel. So not side, and it's the move promotion type. Hold on a second. Move capture piece, and we are going to add because it's the opposite, and then the material evaluation for our side, we want to subtract the piece values for the move promotion type, and then add the piece values for the move piece type, because that's the pawn. And that's what I forgot actually in the make move to do, is that we need to actually, oh wait, we need to add the promotion type. Why did I do this? We need to actually subtract a pawn, because we're losing a pawn technically. Are you able to do eval boards yet? Yeah, that's like next on the docket. Right now, the goal has been move ordering and getting the, what we did was we made this function called check hash that checks if our zobrist hashing is working for every single position. So that's what that's doing, and that was a pain to do. So yeah, I'm just setting up the material evaluation because that's very simple to do. So we're going to add the pawn, subtract the promotion type, then the other side gets the captured piece. In that case, castle we aren't touching yet. En passant, we want to do the same thing. We want to add the captured piece to the not side, and then subtract, wait, that's just literally it. And then for capture, it's the same thing. We want to add the capture piece to the not side. Yeah. What hash? It's zobrist hashing, which is basically every thing on the board has a random number associated to it. Our hashing has all of these predefined random numbers, 781 of them, and basically we index into them what to hash based on the position of all the pieces. So for example, when we capture a piece, we do all of this zoring with the pieces that have moved and the piece that we're taking off of the board, etc., for castling rights and for the en passant square. Basically what that does is it makes it so that we can keep track of our board state at every position that we come across in our search, so that every time we reach a position that we've already reached, we can use the results that we found at that place, if that makes sense. And we worked on that fixing those bugs with that. I wanna test that this evaluation is working properly. And I guess it is. I'm not entirely sure if it is. This is the number we get back from the score at the top, I think. So in that case, I'm getting back 0, which isn't really great. Right? That's what we return score from here. And then that's what we print out, right? Oh no, this prints out the move score, which is different. Let's print out the score. The best move score. Making it with optimizations in place already. Yep, that's the most important thing, because if we can reuse our data as much as possible, then it'll end up a lot more efficient. Score 0, score 0, score 0. If I set it to a different fen, we check best move, score 50, 50, 50. It's hard to really tell if our evaluation is working properly. E2A6 capture is exactly what we got before. It captures a bishop. And then the line is this pawn should capture this knight, which is b4, c3. Yep, and we get it and it's negative 50, which is the opposite of 50 for black right now. So I think that that's correct. I want to run a perfed 4 from this position. Yeah, our nodes for our perfed have really taken I really wanted to say taken a dump. I don't know. Anyway, I think the reason why this was breaking was because we had depth +1, but it doesn't really make sense for it to, I don't know. Maybe it does make sense and I'm just being dumb. All of this seems to be working good. I guess p-square tables are next, now that we have kind of worked out all the bugs. So that's what I'm going to do next, I guess. Also, this doesn't work, I'm just now realizing. I wonder if our quiescence search is ridiculous. I don't think it is, because if it was, then if replacing it with just plain evaluate would actually speed us up. But I don't think it does speed us up. I don't think that this does speed us up. It would speed us up like insane if our Q search was inefficient. But we get to the same search depth with both. And our nodes is actually less with our Q search. So I'm assuming that we're doing that correctly. Okay. I don't really know how this works. Maybe I should delete it. Next up on the docket, we can actually implement really quickly null move pruning, but I forget where it's supposed to go. I forget if it goes in here or up here. We can try it up here. I also don't know how to make a null move. If it's gonna mess up our hashing. But we can try it. I forget what the conditions are for null move pruning. I think you check if you check depth. If depth is greater than or equal to 2, I think we also have to check if we're not in check. I don't really remember. I should probably look this up. I already tried looking it up and I couldn't find the information that I needed. So all we want to do is game side to move equals not game side to move, and then just change our hash with game key and then zor the get turn random, and then that's the null move. And then if do we run Q search from here. Then this would have to go actually under here, because then you're doing Q search anyway. And then you check if this is greater than or equal to beta, right? Wait, you want to do it, you want to undo it either way. Okay, check hash. Oh my god, we got to depth 14. That can't be correct. That cannot be correct, dude. That cannot be correct. I don't know about that one. I don't know about that one. I don't think null move pruning is that good. Hey, what's up, Frumpy? Now it sees d5 e6. What's d5 e6? d5 e6. Take pawn instead of taking the bishop. The fuck? We're gonna do the move and then see if it works, I guess. And then what does it say best move is for black? It should taken this knight, right? Okay, it's giving me different moves. I think we fucked up. Now it's saying a6, d3. Oh, that's a blunder. That has to be a bad move. That has to be a bad move. There's no way. Nice work, bro. I'm building mine in C++. That's sick. Yeah, it's a lot of fun. Just engines are a lot of fun. Yeah, I think that now it's saying e5 d3. I think it's just randomly moving pieces, man. I think it's randomly moving pieces. I think I messed this up. I found a mini PC and installed Fedora server. So you have a server. Do we have graphics? No. I've been very lazy with the whole graphics thing. I'm going to look up null move pruning. I think I'm just gonna do it arena. It's just gonna do UCI. I just don't want to, you know, have to, you know, nodes are saved by reducing the depth of the subtree under the null move. The value of this depth is known as R. Then seeing if the score of the subtree search is still high enough to cause a beta cutoff. Isn't that what I did? Maybe you're not supposed to Q search and you're supposed to actually check the depth. Oh, I think you're supposed to return the score anyway. And then, like, what's also funny is that Adam said that if it didn't make a graphic for this, then I'm not gonna have a girlfriend. Which was so funny. Okay, so This should still, in theory, work, though. Yeah, I feel like getting to depth, that depth is probably not a good sign, though. It sees e2, a6, which is not the move. It's definitely d5, e6. No, e2, a6 is the move, and then at the end it's just ints, and then a d5, e6 capture. Maybe I have to return score, actually. Hold on. I feel like this isn't working. Oh, hold on a second. We changed the turn, so it's the opposite. Okay, so then let's just straight up negamax here. From here, and then just do score. Let's just do depth. Wait, it's depth less than or equal to the lower bound. Okay, yeah, I forgot about that. And then this returns beta now, I think. Okay, now we're back in the realm of correctness, I think. Then let me go back into this fin and see if it griefs. We're actually getting a less deep search now with this. Yeah, maybe I'm implementing this wrong. Wrong. Yeah, I don't know. I may have to come back to this when I read more forum posts or look at my old code base. I think you're also supposed to return score, but I don't think that it should make that big of a difference. But I don't think that we should have a worse search after implementing this. Yeah, our search isn't even hitting depth 4 really anymore. And we have so much branching. Like, if I remove this, we're gonna have so much better. Like, look at our branching. At depth 3, we had an extra, 2 million moves there. So, yeah. Alright, I'm going to peace out. Didn't get a ton done today, other than fix our zobrist hashing and stuff, but now that it's working, and we can be sure that it's working, that's pretty cool. And now that that's working, our PV tracking is working, so that's we get the correct number of PVs all the time, right? Which is neat. It's neat. I guess we have to include tables, or else it's just not going to work. In terms of evaluation, I can probably like copy the tables from somewhere. I know the pesto tables are here. But I don't really know if I should use those or someone else's. Eventually you want to, I think, create your own tables, but I never made my own tables. But yeah, I'm probably just going to do that off stream, the tables, because that's just going to be a lot of boring kind of copying and pasting sort of thing. But as far as I can tell, the material evaluation looks fine. The issue is that we just aren't going, we aren't going that far into the future, I guess, I want to try this. I don't know if that's correct, but I've been kind of going back and forth because some forum post said that I should do it that way. Yeah. I also made this mode off stream that is auto, where it literally just plays against itself. At least I think it does. Unless I broke that while I was doing other stuff. Yeah, I broke it. And this is the part where you kind of want the UCI for, because this is just incredibly impossible to tell what's going on. What I meant to do was it gets a move from this, right? And then you just make move. And then we did display. Whatever's in command display move, display board. Just like literally do this. And now it should display the board as it goes. Hey bro, it's 2 a.m. and I low-key just ruined your sleep by listening to FNAF 4 ambience. That does sound pretty spooky, for sure. Seems to be pretty losing for black right now. F3, F7. F3, F... Oh, that was queen takes. And then it found E7, F7. Which is queen takes back. And then it found E5, F7 capture, which is knight takes queen. And then it found G7, C3, which is bishop captures the bishop. And then it finds pawn captures back. And scary as shit. Imagine a 6-foot animatronic walking into your room, peeking over. Yeah, that sounds horrifying. Now it seems like pretty winning for white all the way down. And now white is just very ahead in material. Just pawn takes pawn. Wait, what? C6, D5. Oh no, pawn takes bishop. Then I want to see if we get to endgame, what it's going to be like. Does the engine use algorithms? Yeah. Well, I mean, not like neural network type of algorithms to, but it uses a few heuristics to order moves, which increases how many moves ahead it gets before it has to make a move. We can monitor how many nodes it looks like. So this is about 2 million nodes it's getting. in about 10 seconds before it makes a move. I'm just like kind of checking to see that the moves that it's making are good. h8 to h4, which is rook down to e1 g1. Hold on a second, e1 g1, but our rook didn't move. Wait, what? Am I reading this right? We didn't have castling, right? But we find e1 g1 on the move list. But I'm 99% sure if we go to this fen, we go to generate, we do see e1 g1 castle. Oh wait, we can castle technically. We can castle. It's just when I move e1 g1 display, it works fine. My strategy, if else, if else, if else. Yeah, that's a pretty fair strategy. That is pretty fair. Yeah, I don't know. Obviously on the fen it doesn't, it shows it as well. It's so strange that I can't recreate this. I wonder if I go from this position again, if I press auto from here, it finds d1, d4. I want to recreate this bug. Now it's just not finding d1, or it's not finding the castle. Let me see perf 1, e1, g1. It just doesn't want to do that move. Oh, there's a bug here, no promo piece found. Okay, so we have some bugs still to work out. For sure. If I play it from here, let me see. it refused to castle there. All right, I'm gonna peace out. I will keep working on this. But yeah, I need to figure out this bug with the castling for sure. Because, you know, sometimes we castle but we don't move the rook, which is weird. Very strange. Alright. Also the whole no promo piece found. Which basically means that a piece tried to promotion capture, but there was no piece there. Which means that our boards get unsynced somewhere. So all right. How do we end up with tripled up pawns? That's crazy. That's wild. Wait, what? Yeah, we capture this rook. That's funny. Alright, I will try to get this thing in arena off stream so that it's less painful to watch the debugging process. But also arena isn't going to make it easier to debug. It'll actually make it harder to debug because it's just going to say illegal move and then get, you know, it's not. This is actually helpful because I know where we're off. But yeah, I'm gonna take a break. All right, peace out.